Right, hello. This one is going to be about structural isomers, and we're going to be able to define them and draw them and name them. Right, so first of all, let's look at these two examples. Um, they're both hydrocarbons, so they're made up of carbon and hydrogen only. And you notice the first one's got 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8 carbons, and therefore it's going to be called octane. It's an alkane. And this one here, we look for the longest chain, and it is 1, 2, 3, 4, 5, 6 carbons in a row. 6 carbons, so it's going to end in hexane. So let's write that last bit down first. Hexane. Then you look for the branching, and you notice that there are 2 methyl groups, and they are on carbon number, if you count from this side, 1, 2, 3, 4. They're on carbon number 2 and carbon number 4, and there's 2 of them. So let's just put dimethyl first. Dimethyl. So just trying to name it backwards. And it's 2 and 4. So 2, 4, dimethyl hexane. If you tried to name it the other way, it would be 1, 2, 3, 4, 5. It would be 3, 5 dimethyl hexane. And 3 and 5 add up to 8. 2 and 4 add up to 6. So you must go with the smallest sum, the smaller number. Right, that's 2, 4 dimethyl hexane. Let's try some more. Oh, before we do that, let's just do the definition for structural isomerism. Molecules with the same molecular formula but different structures. Right. Memorize that one. Right. Examples 2 and 3. What we'll try to do now, we've got the name, let's try to draw it. Okay, remember, look at the last bit first. Pentane. So we draw 5 carbons. 1, 2, 3, 4, 5 carbons. And then you carry on working backwards. You've got 3 methyl. Okay, so carbon numbers 1, 2, and 3. Let's put a methyl group on this one. It doesn't matter which way you name it, which way you number it. 1, 2, 3 this side, 1, 2, 3 that side. So methyl group, CH3. You've done that bit. Now we go over here. Dichloro, 2 chlorines, and they're both on position carbon number 2, 2 and 2. So carbon number 2 and carbon number 2. You've got your chlorines. There they are. So you've got your 2, 2, dichloro, 3 methyl, 1, 2, 3, 4, 5 pentane. You can put the hydrogens in now. Each carbon you have to make sure that each carbon's got 4 bonds. This one's got 1 bond here, so it needs 3 hydrogens. This one's got 2 bonds already, there and there, so it needs to have 2 more hydrogens, 2 hydrogens to make 4 bonds. This carbon here has got 1, 2, 3 bonds already, so it needs 1 hydrogen only. This carbon here has got 1 bond, it needs to have 3 more, so it needs to have 3 hydrogens. Okay, let's do this one now. 2, 2 dichlorohexane. Remember, you start from the back hexane bit first. So 1, 2, 3, 4, 5, 6. There's the hexane. Dichloro, 2 chlorines, and they're both on carbon number 2. So carbon number 2, Cl and Cl. Right, I'll put the hydrogens in. 3 there, 2 there, 2 there, 2 there, and there'll be 3 here. Okay, remember it's the carbon that bonds with the carbon. That's why I've drawn the hydrogens on the left over here. Okay, now the question is, are they isomers? Well, let's have a look. How many carbons each one has? 1, 2, 3, 4, 5, 6 carbons, C6. Let's count how many hydrogens. 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, H12, and it's got 2 chlorines, so Cl2. That's the molecular formula. Let's look at this one. 1, 2, 3, 4, 5, 6 carbons. Hydrogens 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So H12 and 2 chlorines, Cl2. So you notice that the molecular formula is the same. They have different structures. So they are, yes, they are isomers. Right, let's go to the next one. Examples 4, 5, and 6. Name these. Right, remember how we named them? The longest chain. 1, 2, 3, 4, 5. That looks like the longest chain. What about this one? 1, 2, 3, 4, 5. That's also one long chain. 5 seems to be the longest, so we'll go with this one here. That's the longest chain, 5. So we know it's going to end in pentane. Pentane. There we are. And we have, if you count the number of methyl groups, 1, 2, 3 methyl groups. So it's going to be trimethyl. So we'll write that bit next. Working backwards, as you can see. Trimethyl. I forgot enough space there. Yep. Trimethyl. And now say where they are. So carbon numbers, let's count from this end. 1, 2, carbon number 2. That down here. 3, 4. There and 4 there, so 2, 4, 4. Or let's count from this side. 1, 2, so 2 and 2. 2, 2, 1, 2, 3, 4. 2, 2, 4. So which one's it going to be? 2, 4, 4 trimethyl pentane or 2, 2, 4 trimethyl pentane. Remember, go with the lowest sum. We've got that adds up to 10, that adds up to 8, so it's going to be this one here. So just rub this one out. Okay, and that will be your name. Right, let's name this one. Remember, longest chain first. 1, 2, 3, 4, 5. So it's a pentane, and it's got 1 methyl group. Methyl, just make the space, right, and it's on carbon number 2, 2-methyl pentane. This one here, longest chain, 1, 2, 3, 4, so it's going to end in butane. Butane, and you got 2 methyl groups, so it's dimethyl. Right, dimethyl. Yep. And that's a 3. And you got they're on carbon number 2, so 2 and 2. So I'm going to put 2, 2, 2, 2 dimethyl butane. There we are. Right, let's go to the next page. Right, name them and say what type of isomers they are. So let's have a look at these. Notice I've just drawn the skeletons here. I've not put the hydrogens in just for speed. But they're still fully saturated. They're still alkanes, if you like, the chains. This time you have an OH group on them. See that? These have got OH groups on them, therefore they are all alcohols. Right, let's name this one then. First, longest chain, 1, 2, 3. So it's going to be propan. And the OH group is on carbon number 1. So it's propan-1-ol. Propan-1-ol. And then you have, if you carry on counting from this side, 1, 2, because that's where you started, propan-1-ol. Propan-1-ol. And the second carbon's got a methyl group, a CH3. So it's on the second carbon, 2, 2-methyl. Come on, yeah. 2-methyl propan 1-ol. This one, 1, 2, 1, 1, 2, 3, 4. Butan 1-ol. Butan 1-ol. This one over here, 1, 2, 3, 4. Longest chain is 4, so it's but, and the OH is on the second carbon, so it's going to be butan 2-ol. Butan 2-ol. And this one here, right, longest chain is 1, 2, 3. 1, 2, 3. You can go this way. Longest chain is 3 carbons, so it's prop. The OH is on the second carbon, and so is a methyl group. So we've got 2-methyl, and then propan 2-ol. Propan 2-ol. There we are. Right, let's go to the next one. Right, van der Waals forces now and intermolecular forces. Molecules, organic molecules like these hydrocarbons, when you've got them together, what happens is that they attract each other. There is an attractive force between the molecules. Now, the longer the molecule, then the greater the attraction, and therefore the greater the boiling point. If you look at butane, it's got 4 carbons, and pentane's got 5, hexane's got 6. So you'd expect that as you go from butane to pentane to hexane, the boiling point will increase because the molecular mass is increasing. You could also say that the surface area is increasing, and you could also say the length of the molecule is increasing. So let's just write this down. Increase in boiling point. Okay, let me just show you the kind of attraction I'm talking about. If I draw another molecule of butane just here, 2, 3, 4. If I draw that, then the attraction, the van der Waals attraction, is between the 2 molecules like this. Look, all the way along the molecule. That attraction is called the van der Waals force, and often is called the IMF for short. You can write that down in the exam paper. IMF, intermolecular force between the molecules. And over here, obviously, it's a longer molecule, therefore bigger attraction, bigger van der Waals. It's more difficult to separate the molecules, therefore boiling point's higher. Right. If you look at this molecule here, this is an isomer of that one. Let's just see. 1, 2, 3, 4, 5, 6 carbons. 1, 2, 3, 4, 5, 6 carbons. Yeah. So these two, that one there and that one there, are isomers of each other. This one is actually branched. You can see that the CH3 branching off the second carbon. Now, because of that, these 2 molecules can't get close to each other like hexane molecules can. These can get really close to each other like this. 4, 5, 6. 1, 2, 3, 4, 5, 6. But these 2 can't get close to each other. Therefore, that limits the kind of attraction that they can have between them. Therefore, the boiling point of this 2-methyl pentane is going to be much less than the boiling point of this hexane. The intermolecular force is smaller. Okay, next page. Right, let's look. Yeah, that's what I've just explained. The difference in the boiling points between them. Okay, anything else? No. Right, that was structural isomers and drawing and naming them. Okay.